Welcome to Mr. Hamilton's Math Bites. This video is about arithmetic series, part 2, looking at some examples. So it's important as we go through these that you have your equations that we derived on the last page in mind. You may even want to write at the top here as we use them. We have 3 examples that we're going to do here. The first says this: determine the sum of the series where S10, so that S10, that means the sum of the first 10 terms, where a equals -4 and d equals -3. So for example, your series is going to start at -4. Your next term is going to be -7. Next term, -10, etc. And you want to determine the first 10 terms. Now, this is straightforward, and we could probably do it just logically by writing out those 10 numbers and adding them together. But again, we want to know a way that if we're given something like 100 numbers, as Gauss was, we could calculate that. So we need to do this actually using the formula that we derived a minute ago. So for part A, our formula is going to be Sn equals, well, we don't know the last term, so we're not going to use the second formula, we're going to use the first one. So n times 2a plus n minus 1 times d. I guess these are square brackets. It really doesn't matter if it's square or round brackets, just so long as it's clear. But usually square brackets are used with round brackets just to make it a little bit more clear. We know there are 10 terms, so S10. We know that the a value is -4. We know that the n value again is 10. And we know that the d value is -3. We're going to divide all this by 2. I'm really going to substitute that in your calculator and find a number. So it ends up being 10 times -8 plus 9 times -3 divided by 2. And so the 10th term would just be a value of -175. It's very important that you do not add until multiplying. So use the distributive property here. I see that mistake made quite a bit, so don't add until you do that. The other thing you can do pretty quickly here is recognize that if this value is 10 and this value is 2, you could just get rid of the fraction and write a 5 out in front instead. That would have worked just as well. Now for the second example. S20, so the sum of the first 20 terms for this series. S20. Well, we know that the first term is -11, but it's not just -11, there's a variable in there too, isn't there? -11m. The d value can be found by taking a later term and subtracting the one right before it. So we're going to be careful here to make sure we do the right signs. -2m is the later term, and I'm subtracting -11m. That gives me +9m. An important distinction to notice there. We're subtracting a negative in that case. So I know what the d value is. I know what the a value is. Again, I can use that same formula. Sn equals n times 2a plus n minus 1 times d, all divided by 2. So this is S20. We get 20, and I'm going to kill that fraction pretty quickly here. 2 times -11m plus 20 minus 1 times 9m. By dividing by 2, that 2 and 20 give me 10 in front. I'm just going to scroll down a little bit so I can finish writing the answer, but you should be able to take it from there. You get 10 times -22m plus 19 times 9m. Again, until you've multiplied this, don't even think about adding. So 10 minus 22, or -22m, plus 9 times 19 is 90 and 81. It's a quick way that you can do that math. You can do 9 times 20 is 180 minus 9. You get 171 times m. And if you continue to simplify that, you don't even need a calculator here. 171 minus 22 is 149. And you're left with 1,490 times m. and that is the sum of the first 20 terms of that series. So in that case, negative 11m plus negative 2m plus 7m plus, so 20 terms where this is the first one, this is the second one, this is the third one, all together add to positive 1490m. And it's important to make sure you go through that as a check and say, hey, does that actually make sense? And it's obvious that the third term already of the 20 terms is already positive. So it makes sense that's going to be a positive number and likely a very large positive number because it's jumping by 9 each time. This last example is a little bit unique. We see here that we're not told the number of terms. So it's obviously going to have some differences. Let's see if we can list everything that we know and where to go from there. We know first off the a value is 3. That is often also referred to as T1. Okay? We also know that this is arithmetic because we can see that it's going up by 5 in each case. The d value is equal to 5. It's nice and clear there. Just be careful that it's not changing signs. It's not, so that's not affecting anything as far as negatives and positives. So we have an a value, have a d value. We don't know what the n value is, and we also don't know then what the sum is. So we have two values that we don't know. And so if we know an a and a d, the only equation we really have to work with is this one. But we also know a Tn. We know that Tn is 58. And so we also could solve it using this equation. So looking at each of these equations, I know A, I know D, I know T1, I know Tn. I don't know two things in each of those equations. So one thing I could do is I could put those two equations together and solve it, but there's even an easier equation to solve here. And that's your term number for an arithmetic sequence. And that was A plus n minus 1 times B. And so in that case, what we have is you could say, I know A, I know D, and depending on what term number I'm trying to solve for, I know what that is. And so I know what the term value is of the last term. What Tn is the last term. And so I could solve for the last term, and once I could find that last term, I could then substitute that into the second equation I've written up above. So Tn is equal to A times plus n minus 1 times D. Tn is going to be 58. A is going to be 3. And D is going to be 5. Gathering like terms together, I get negative 2 plus 5n is equal to 58. And now, bringing the 2 over, I get 60 is 5n. Divide by 5. N is equal to 12. That means there are 12 terms in this sequence. Or sorry, in this series. So now that I know the n, number of n's, I now know this, and I can solve for this. Right? Anytime you're given two equations with two unknowns, we can solve that. So in other words, if we're not knowing two things in one of these two sum equations, either this one or this one, we can go to the equation that we have for the term of an arithmetic sequence and use that to help us find the n value, which in turn allows us to use one of these equations to solve it. So I'm going to use the second equation. So I'm going to say S12, I know how many terms there are now, is equal to 12 times the first term is 3, the last term is 58, divided by 2, and then that 12 and that 2 are going to simplify nicely for me. That's becoming 1 and 6, and so I'm going to get S12 is equal to 6 times 3 plus 58 is 61, and that gives me a grand total of the 12 terms to be 366. And there you go.